Uranus and Neptune are intriguing enigmas of our solar system. Their existence, especially in their current locations, poses significant questions to scientists. Recently, the James Webb Space Telescope, JWST, provided a stunning image of Neptune, the most detailed in over 3 decades. But this isn't just another captivating photo. It offers a deeper look into the icy giant's mysteries. Neptune resides in a frigid region of the solar system, dominated by ice and frozen gases like methane, ammonia, and water. This new view from JWST sheds light on what lies beneath Neptune's dazzling blue surface. As one of the least explored planets, studying Neptune has been a challenge due to its vast distance from the Sun, which slows the gravitational interactions that lead to planetary collisions and formations. But JWST has revolutionized our understanding of this distant world. The best look at Neptune in over 30 years. Since Voyager 2's 1989 flyby, our best look at Neptune came from that single mission. Voyager 2, launched in 1977, was designed to explore the outer solar system and then venture into interstellar space. While the Hubble Space Telescope later captured some images, the level of detail was limited. All of this changed with JWST's launch in September 2022. Using its near-infrared camera NIRCam, JWST provided an unprecedented view of Neptune. In infrared light, Neptune appears much darker than its iconic blue hue, as methane gas absorbs red and infrared light. Despite this darkness, bright streaks and spots are visible in the image. These are high-altitude methane ice clouds reflecting sunlight, appearing almost white in the infrared spectrum. For the first time, JWST also captured Neptune's delicate ring system with extraordinary clarity. Scientists believe these rings are composed of icy particles, previously glimpsed by Voyager 2 but difficult to study in detail. A narrow, bright line around Neptune's equator, likely indicative of vigorous atmospheric activity such as powerful winds and storms, adds to the planet's mystique. Atmospheric phenomena and dynamic weather. JWST's image also highlights a previously known vortex at Neptune's south pole, and reveals a continuous band of clouds encircling higher latitudes. This new data allows scientists to analyze Neptune's atmosphere and chemical composition with greater precision, using advanced light filtering techniques. Neptune's atmosphere is a fascinating mix of gases, liquids, and ices. It's primarily composed of hydrogen, helium, and methane, the latter giving it its vibrant blue color. Methane absorbs red light, leaving blue wavelengths to dominate the reflected light. This mesmerizing blue glow earned Neptune its name after the Roman god of the sea. However, Neptune's atmosphere isn't just beautiful. It's also highly dynamic. Its weather patterns are extreme, with the fastest winds in the solar system reaching speeds of up to 1,350 miles per hour, nearly 7 times faster than the strongest hurricanes on Earth. These fierce winds drive massive storms, some larger than the entire continent of North America. Voyager 2 famously captured one such storm, the Great Dark Spot, in 1989. Yet, by 1994, when Hubble revisited Neptune, this storm had disappeared, replaced by a new dark spot in the northern hemisphere. Unlike Jupiter's Great Red Spot, which has raged for centuries, Neptune's storms are short-lived, appearing and disappearing within a few years. These transient storms reveal significant differences between the atmospheres of Neptune and Jupiter. A new era of Neptune exploration. Despite its captivating features, Neptune remains one of the least studied planets due to the lack of dedicated missions. JWST's observations mark a major milestone in Neptune research, offering a wealth of new information about its rings, atmosphere, and weather systems. Neptune orbits the Sun at an astonishing distance of 2.8 billion miles, over 30 times farther than Earth. As the 8th planet in the solar system, it also holds the title of the most distant, following Pluto's reclassification in 2006. It is the 4th largest planet by diameter and the 3rd most massive, slightly outweighing its twin Uranus. Discovered in 1846, Neptune's existence was first predicted mathematically by English mathematician John Couch Adams and French astronomer Urbain Le Verrier. Their calculations led to its observation by German astronomer Johann Gottfried Galle, making it the first planet discovered through mathematical prediction rather than direct observation. Unanswered questions and future prospects. Neptune's secrets, from its atmospheric chemistry to the behavior of its storms, continue to captivate scientists. The JWST's ability to capture the planet in extraordinary detail offers hope for uncovering these mysteries. For instance, its fine ring system, first observed by Voyager 2, is now being studied with unprecedented clarity, promising insights into the planet's formation and evolution. As technology advances, the prospect of a dedicated mission to Neptune becomes increasingly realistic. Such a mission could revolutionize our understanding of ice giants and the outer solar system. Until then, the James Webb Space Telescope stands as our best tool for exploring this enigmatic planet, unveiling Neptune's secrets one image at a time. For years, scientists tracked a massive storm on Neptune, expecting it to follow the usual path towards the equator, where Neptune's storms typically dissipate. This process is influenced by a unique climate phenomenon tied to the planet's rotation. On Earth, this is known as the Coriolis effect, a force that deflects winds and shapes storm patterns depending on their location. Picture a spinning carousel. Objects near the edge move faster than those closer to the center. Similarly, on Neptune, storms originating near the poles are pushed southward by the Coriolis effect. As they near the equator, the effect weakens, causing the storms to lose strength and eventually disappear. However, the storm observed in 2018 defied expectations. Instead of fading near the equator, it reversed course in 2020 and headed back north, a behavior that left scientists baffled. This unusual movement was captured by the Hubble Space Telescope, which has been observing Neptune's dark spots for nearly 30 years. While some storms appeared to vanish completely, others seem to reappear in the same region, leading researchers to speculate they might submerge into Neptune's deeper atmosphere before resurfacing. Unfortunately, the exact mechanisms remain a mystery due to limited data on the planet's deeper layers. Adding to the intrigue, this storm seemed to spawn a smaller companion, a mini version of itself. While some computer models predict that weakening storms near the equator could shed smaller vortices, direct observation of this process is challenging. Unlike most dark storms on Neptune, this one lacked the usual bright white methane ice clouds typically found around these systems. Methane gas in the storm's high-pressure center is usually carried upwards, where it cools and forms ice crystals. Similar processes occur on Earth, where moist air rising over mountains creates orographic clouds. Interestingly, these bright clouds, observed in 2019, disappeared by 2020. Whether this disappearance is connected to the storm's peculiar behavior remains uncertain. Studying Neptune is notoriously difficult. It's incredibly distant, appears tiny in telescopes, and its atmosphere changes rapidly. A dedicated mission to Neptune, akin to the Cassini probe's exploration of Saturn, could provide critical insights. Such a mission might even contribute to the search for Planet X, a hypothesized celestial body far beyond Neptune. Planet X, sometimes called Planet 9, is believed to have a highly elliptical orbit, taking millennia to circle the Sun and remaining undetectable under current observational conditions. A future mission to Neptune could not only unravel its atmospheric mysteries, but also aid in the discovery of this elusive planet. Meanwhile, Neptune's largest moon, Triton, also offers exciting possibilities. In images captured by the James Webb Space Telescope, Triton stands out with its distinctive bright blue-green hue. This coloration is partly due to the imaging filters but also reflects its icy, smooth surface, which is largely devoid of craters. Unlike most moons, Triton has a retrograde orbit, traveling in the opposite direction of Neptune's rotation. This unusual trajectory suggests that Triton was likely a wandering object from the Kuiper belt, captured by Neptune's gravity millions or even billions of years ago. Triton's captivating history and potential subsurface ocean, hinted at by signs of ice volcanism, make it a prime target for future exploration. Neptune's other moons, though smaller and less well known, are equally fascinating. With irregular shapes and sizes, many of these moons, like Despina and Galatea, are thought to act as shepherds, using their gravity to cluster particles within Neptune's rings. While Neptune's rings lack the grandeur of Saturn's, they feature intricate arcs, clumps, and even braided patterns, showcasing a complexity that continues to puzzle scientists. Triton, at 2,700 kilometers in diameter, is larger than Pluto and rivals our moon in size. Its unique orbit, striking coloration, and potential ocean beneath its icy crust make it a standout among celestial bodies. However, it's not just Triton or Neptune's rings that captivate researchers. The intricacies of Neptune's atmosphere, its moons, and their dynamic interactions highlight the need for deeper exploration. As we await more discoveries from the James Webb Space Telescope and dream of a dedicated Neptune mission, the mysteries of this distant ice giant and its entourage of moons remain some of the most compelling enigmas in our solar system.